What up? Your boy C. Rizzy coming at you with Unit 1, Lesson 5, Exploring Angle Pairs. Today's joke: what do you call a number that can't sit still? Alright, we'll figure that out later. Okay, today's essential question: what type of relationships do angles have to one another if they share a vertex or if they do not share a vertex? And our objective is to identify special angle pairs and use their relationships to find angle measures. Special angle pairs can help you identify geometric relationships. These angle pair relationships are true whether angles share a vertex or not. Okay. Adjacent angles are two coplanar angles with a common side, a common vertex, and no common interior points. So there are angle pair relationships where you do not have to share a vertex. This is one where you do have to share a vertex. So adjacent angles here share a common side. So here's the common side that they share, and a common vertex, which is the point of the angle. Okay, those are adjacent angles. They're just angles that sit next to each other. Vertical angles are two angles whose sides are opposite rays. Okay, so 1 and 2 here are vertical angles, and 3 and 4 are vertical angles. Complementary angles are two angles whose measures have a sum of 90 degrees. Each angle is called the complement of the other. So here in the picture we see angles 1 and 2. Okay, this is a picture where the angles are adjacent and they share a vertex. In the other picture, the angles are not adjacent. They're just two angles that add up or sum to 90 degrees. Okay, again, you have the same thing in the bottom. Supplementary angles are those that sum to 180. So in my bottom, I have two adjacent angles on a straight line. And we know a straight line is a straight angle that measures 180 degrees. And over here, my picture must have gotten cut off. I've got an angle here, and I should have another angle. And if they were to sum up to 180, 137 plus 43 degrees add up to 180. And those two angles would said to be supplements of one another. Okay, so looking at the picture, name at least one pair of angles that are adjacent, vertical, complementary, and supplementary. So all my adjacent angle pairs, I've got angle 1 and angle 2 are adjacent, and angle 4 and angle 5 are adjacent. That's all I see there. Vertical, you have angle 3 and angle 6, because they are opposite, they're across from one another. Complementary, ones that add up to 90. Angle 1 and angle 2 will sum to 90 degrees because they're next to a right angle. As well as angle 4 and angle 5 are supplementary to one another. Supplementary angles, angles that add up to 180 degrees. Well, I could say that angle 3 and angle 6 are supplementary because they're both 90 and they'll add up to 180. And that's it for pairs. I could say that angle 1, 2, and 6 are supplementary because they sit on a line, but they're not a pair. There's more than two of them. Okay, use the diagram to the right. Are angle AFE and angle CFD vertical? So AFE is this angle, and angle CFD, which is this angle. Are they vertical? So let's go back to vertical. Vertical angles are two angles whose sides are opposite rays. So let's find out if we have opposite rays. So let's see, here's my vertex. So on AD, yep, that appears to be opposite. They appear to be opposite rays. And let's try the other way. C and E, they appear to be opposite rays as well. So then, yes, they are vertical angles. Okay. Another way to think about it is not just opposite rays, but vertical angles are formed when two lines intersect. So if I had any set of two lines that intersect here, then angle 1 and 2 would be vertical, and angle 3 and 4 would be vertical also. Two angles form a linear pair, then they're supplementary. So what is a linear pair? A linear pair are just two adjacent angles that sit on the same line. So if I drew a line, assuming that that's a straight line, and drew some ray coming out from the line, and I call this angle 1, and I call this angle 2, these are adjacent, and they form a linear pair, so that the measure of angle 1 plus the measure of angle 2 has to add up to 180 degrees. So let's just say, as a for instance, if angle 1 was 120 degrees, then angle 2 would have to be 60 degrees. Solve for x given that the two angles are a linear pair. So as we just said, if you have two linear pair angles, 1 plus 2 has to equal 180. So if I want to solve for x, I first need an equation. Say that every day in class. So 2x plus 24 plus 4x plus 36 has to equal 180 degrees, which is what we just said. Okay, take a minute to write down this equation and solve it out on your own. Okay, I solved it out and I got x to be 20. I hope you did as well. So to double check ourselves, I'm going to plug in 20 for x. Okay, over here I get 40 plus 24, which is 64. Over here I get 80 plus 36, which is 116. 116 plus 64 equals 180 degrees. Therefore, I know my answer is correct. Okay, using an angle bisector. So what does it mean to be an angle bisector? So if I'm an angle, if I'm some arbitrary angle, arbitrary just means any, and I'm bisected by some angle or by some ray, what it means it's to cut into two equal pieces. So bisects, cuts into two equal, we'll say, parts. Okay, so I had some ray Km which bisected my angle JKL. If JKL, which is my larger angle, is 72 degrees, what is JKM? Well, we just said that if it bisects, JKM and MKL are equal to one another. So what two angle measures are the same and add up to 72? All we have to do is, what is 72 divided by 2? And that's 36. So each angle must be 36 degrees. Alright, that's all I got. Do as much as the guided notes as you can. Make sure you come in tomorrow with questions.